Hello, we are going to do a real quick little lesson on the types of linear systems. First off, the major categories are consistent and inconsistent. Now, every textbook I've ever seen merely gives you definitions, doesn't explain a way to think about this. So that's what I'm going to do. So first, if you write, this is our main assumption, if you write a system of equations, you're going to assume that there's a solution. Otherwise, why do it? Why bother? Who cares? There's no solution. Okay, so we assume there is a solution. That's our assumption. All right, now the possibilities. Consistent with my assertion, there is a solution. At least one solution. That's why I bothered to write the system. That is consistent. It is consistent with my belief that there is a solution. Inconsistent with my assertion is that there's no solution. So no solution to the system is inconsistent with my assumption. That's the difference between consistent and inconsistent. It's a difference of solution or no solution. Now, within the category of consistent, so there is at least one solution, we have two different possibilities. Okay, dependent and independent. You'll never get inconsistent and either one of these. You're not going to get inconsistent dependent or inconsistent dependent. No, it's going to be inconsistent or consistent dependent or consistent independent. So dependent versus independent. First we have dependent, and this couple, everyone knows a couple like these two. They're always together. They're inseparable. Wherever one goes, the other is there. They're always together. You whisper secret into one ear and it automatically goes to the other. Okay, we know these couples. They're just constantly together. They are dependent upon each other. Well, the dependent system is always together. I'll give you a better explanation of how it works in systems in a minute. All right, now we have this other kind of happy-go-lucky couple. They're good friends, and they go out every once in a while. They hang out together, but they have their own separate lives. You know, she plays soccer, he plays basketball. They are independent. Okay, they come together occasionally, but not all the time. All right, now, dependent, like our couple, dependent lines are lines that are graphed directly on top of each other. They're together into infinity. They are always together. They are dependent. So you can see here is a picture. I'm looking at the air, my finger. There we go. Is that better? I can't tell. Okay, there you go. Dependent. Notice picture of a dependent system. The two lines are graphed right on top of each other. They're smack dab on top. Boom, boom. Okay, there are dependent couple. Independent lines cross once or twice. Well, when you're using just linear systems, it can only cross once, but they cross a specific number of times. They are independent. It's like our couple that are hanging out and going to a movie together one day, and 3 or 4 days later they go to dinner, right? They're just independent. Those are independent lines, only cross in one or more places, but a finite number of places. The dependent, they're the same line, so it's on top of each other. Okay, I'm sorry. Okay. There are three options. This is a summarization. Consistent dependent means equal lines, equal equations. Notice they're graphing one on top of the other. Okay, you can see there's a green line and a blue line there right on top of each other. Those are consistent dependent. Consistent means solution. Dependent means infinite solutions, because they are any point on that line would be a solution to both equations. We have consistent and dependent. Consistent means there is a solution. Independent means it is a one solution for lines. All right. Inconsistent, different lines, equal slopes. Notice they're parallel. These two are never going to cross. So Inconsistent means no solution. All right, look down at the bottom. Notice consistent dependent is infinite solutions. Consistent independent has one solution. Inconsistent has no solutions. Okay, real quick, I wanted to show you with lines, this consistent dependent thing is only one solution. But if I have a parabola and a line, I could have two solutions. If I have a parabola and an ellipse, I could have four solutions. Okay? So those would still be consistent independent, even though there's more than one solution. Right now we're dealing with just lines, so you have just one solution. Okay, and we're done.